Okay, good morning. Welcome to the Wednesday issue of Basic Toolmaking. I do see some familiar faces from my session on Monday. Thanks to our awesome sponsors and to the organizers of the PSConf who ultimately made this possible. Thanks to you for getting up and showing up at this ungodly hour after yesterday's social event. I'm Evgenij, coming from Berlin. I will not bore you with a long list of credentials that allow me to speak at conferences, but which is maybe important in the context of this talk is that I work as a consultant. So I hop from one engagement to the next, and no two customer sites are the same. So over the years, I had to learn to make do with whatever is there on site. And this is kind of a collection of life-saving practices that I picked up over the years when it comes to storing persistent data in our scripts. So we will talk about why do we need to store persistent data or persist data from our scripts in the first place. And then I will share some thoughts on how to choose the right storage strategy for that data and, of course, how to implement that. Why, oh why, do we have to persist data in PowerShell? PowerShell is great for juggling data in memory. We have objects, obviously, we have collections of those objects, arrays, and hash tables, and array lists, and if you drop down one level deeper to .NET classes, so you have even more types of collections you can use to achieve your data juggling goals. But sometimes you have to actually keep that data for a longer period of time. Or you need to preserve that data in case your script dies. Or in the case the system your script is running on dies, right? So what are the typical use cases? You need to provide some configurations. It's usually a one-way street. Humans will edit those configurations and the scripts will load them and run off it. State persistence between executions. I talked about it briefly in my other talk. If not everything could be accomplished during the script execution, it might be a good idea to have the next execution pick up where we left. Or compare the current state of the system to the last recorded state, or whatever. Same execution, different executions of the same script. Of course, state persistence during prolonged executions, because the longer your script is running, it could be doing something, it could be waiting on some systems to come back online, whatever. But the longer you are doing something, the more probable it gets that something goes wrong in the interim. So it could be a good idea to preserve the state of what has been done already. So if you need to pick up afterwards, you don't need to redo all the steps. State consolidation from multiple sources. If you do like systems hardening, monitoring, inventory, then you might want to have one single data pot you throw similarly looking data sets from different systems. And of course, when juggling data has been the target or the goal of your script in the first place, you might want to persist the result for the posterity. I'm explicitly not talking about logging today, because it's a chapter to itself, and On the other hand, very much has been said and done about logging in PowerShell and otherwise over the years, but it's a use case as well. Logging is, of course, also persisting data that you generate in your scripts. So what? Thank you. What do we need to ask ourselves when planning our data storage strategy? Because if you get confronted with a task and decide, okay, this task is best resolved by means of a PowerShell script, you should question that as well, by the way. But since we are at the PowerShell conference, I assume you are past that phase. So you start writing PowerShell script. You think, okay, I may be better off if I persist this state. So what do? I don't know. I just do JSON and put it into PS script root because all the cool kids do that nowadays, right? But that not be optimal, and then you have to refactor. And if that script got deployed to a multitude of systems, you have to redeploy, and you might lose the results from the previous execution if you change your data storage strategy. So it's definitely worthwhile to ask yourself some questions first and do a little bit of planning. So what are we ultimately trying to achieve here is to use the right tool for the job. So the file format or data format, a storage facility that fits the use case. This is my personal, coming from my consultant life, have to as few dependencies as possible. That might not be the case where you work. If you only work in one environment and you have a say in what does get installed on those machines, you can absolutely introduce dependencies if you know they will be there at execution time. Cross-platform, it's possible. If possible, it's a new one. But since we are managing Linux and macOS systems and BSD systems and whatnot, it may be worthwhile in some cases to make a script including the data storage technique used in it cross-platform. PowerShell 6 or 7 makes that possible, but of course there are some limitations to that. If you need to process large amounts of data, performance can become an issue. I will not go into that today. I did a session on that 2 years ago in the online edition of PSConf. Tobias Weltner did a lightning talk on that, I think, yesterday in the theater. So there are something to watch out for if you work with large amounts of data. So the questions that helps with planning are simultaneous access from multiple instances. Those can be multiple systems separated by a network. Those can be multiple processes on the same system, on the same machine. But they need not necessarily all be PowerShell scripts or things under your control. You may have to interact on a data source with some manufacturing system. And that system awaits your input to the data source, and that system writes something back, and you have to process that to provide the next meaningful iteration, right? So multiple simultaneous access, and this will require certain storage technologies we will talk about in a minute, and also placement connectivity of these data ports, data sources or data targets, depending on whether you read or write, and of course authentication against those sources. Will carbon-based units be involved at any stage? This is you here. Human readability must not necessarily be of your concern, but it can. So it helps choose the right format and technology for data storage if you know if this is going to be read and edited by humans. And of course, where humans are involved, we are at an international conference here, languages and locales become a concern. And what kind of data retention will apply? So logging is the best example. I promise not to talk about logging, but in this instance, logging is the best example to illustrate what I'm talking about. So you log some activity on a computer and the computer dies. So logs could help in your post-mortem of that computer, but for that, you need to store them off that machine at execution time, right? So if you need to survive, or if you need your persisted data to survive any possible catastrophic event on the machine running your script, you need to provide for storing that on site and, if possible, in real time. So, technologies. First off, PowerShell does many things very good, and one of them is working with flat files. I'm sure everybody here has done something with some kinds of flat files in the past. Like I said, PowerShell is all about objects, and for storing objects in flat text files, there are multiple options in PowerShell. We've got PS data files. Everybody knows them from module manifests, but they have, of course, a purpose of their own. You can use them for localization. There is a commandlet, import localized data, that allows you to import a PSD file. A PSD file is a glorified hash table. It's a hash table without putting it into a variable. It's just a hash table in the usual PowerShell syntax, put in a text file. Which means it's really simple to import that thing. You can use import localized data, or you can just .source that and pipe that into a variable of your choice. It's up to you. But if you were to export that, you need to provide a text file with a valid hash table syntax for that to work, right? So this is an exercise that is usually not worth your while. So it's good for configurations where humans, PowerShell experienced humans, would basically compose that hash table. VS Code and ISE both provide syntax checking and tab completion, and then you just load it. But it's not very suitable for actually exporting data. For exporting data, there is CLI.XML. I'm sure everybody knows that as well. This does the very best job of all the available options. This one does the best job of object preservation. You get all the properties exported into a XML-like format, and if you import it, then the properties are back there. They have mostly the original data types. You don't get methods back apparently, but it's a really useful format if carbon-based processing is not involved, because there is very much overhead in those files. We'll look at that in a second. Yeah, it's not very human readable, but if you need to persist data, rich object data with many properties, with arrays of properties, or arrays in properties, then it's definitely your good friend here. JSON, because all the cool kids do JSON nowadays, right? it's a very good balance between human readability and machine readability. So by all means, go ahead and use JSON. 2 things to watch out for. It's not available in PowerShell 2. So if you have to script for PowerShell 2, sometimes like I do, there is nothing there that will help you. And there aren't export and import JSON commandlets, by the way. It's only convert to and convert from. So persisting JSON, you need to write yourself with get content, send content, etc. And the other thing, JSON does not persist the original object class, which is not a problem most of the time, but do not try storing a hash table in JSON. You will not get a hash table back. You will get a PS custom object that has all the properties derived from the keys of that hash table, but that is not the same thing. Because you can't export JSON, re-import it, and then do like contains key. The re-imported JSON will not have that method. Last but not least, XML is an industry standard for machine readability. I'm sure there are people here in this room who can read XML in their sleep. I can't. I always need to concentrate if I'm confronted with an XML file. But it's a good portable standard. And if you need to interact with other systems according to their rules, if you're not able to set the rules of engagement for the data communication, then chances are you will get to work with XML. It's not very easy to work with. .NET has an XML data type, so if you do it often, you will get the hang of it. But it's not something that is easy to do at the first try. So then, before we drop into the demo, of course, there are also Scalar values and collections of Scalar values in PowerShell. For tabular data, you can use CSV, industry standard. PowerShell conforms to that standard. And while the delimiter is variable, so you can make your CSV to a TSV, for instance, by using tabs for delimiting the fields. You cannot change the qualifier, but that's not contained in the RFC either, so it's not a loss of functionality. You could always do multi-line text files, normal text files. You compose some strings and drop them into text files and read them back. Everybody knows those guys: get content, set content, add content, or out file, or append file. Those are not identical when working with complex objects. Problem with text files is there is no real random access to those guys. So if you're working with long text files and you need to access something in the middle, you usually end up reading most of the file. Same goes for single line text files, so where you basically have a bunch of row text without line breaks, or if there are line breaks, then they are part of the text and not line delimiters. Here you could achieve read random access if you drop down to .NET classes like StreamReader and so on. You can skip like the first 2 kilobytes. But again, there will not be random write access to those files. You need to read them and write them back after you apply changes to the data. And last not least, if you work with some arcane systems that only understand binary files because they are from 1960 and every programmer developed their own data format, there is nothing in PowerShell that will help you. You just treat those files as byte arrays and try to make sense of the file structure. There was a talk at this conference, I think in 2016 or 2017, that dealt with it in great detail. Look the videos up if you're interested. But it's the only way to process data delivered by some third party. And this introduced some common problems. Of course, in coding, if you do cross-platform and write simultaneously from Linux and from Windows, you could get into this situation where there are different line breaks or different encodings. In certain updates, like I said, it's usually a complete rewrite. We will see how well that works in a second. And logging can get in the way if you try to access these files simultaneously from multiple sources. Let's look at a couple of very simple demos. I'm unprepared. But then I can show off start demo. Flat files. So that's what a PSD file could look like. It's just again a hash table in a PSD1 file, and you could import that with import localized data, and the imported hash table goes into input data. Or you can fix the locale if you know that there might be different ones. Then you can say, I only need the data for this UI culture. Or you can use a fixed name, which is what we saw before I closed it. But then the file needs to be placed into the PS script root path. And this is basically what happens if you run it. It just imports this hash table into the variable input data, and you can access that like any other hash table. Nothing fancy here. Now, let's look at CLI XML as compared to JSON. Here, we just retrieve a process object from our own process running the ISE. As most of you will know, it's got a boatload of properties. Really many of them. Some methods. But let's export that to CLI XML and JSON and just have a quick look at the difference. Here's the JSON representation. Everything is there in this JSON format. And here's the same thing in CLI XML. It was temp files, but as you can see, this stuff is not very human readable, right? You ultimately find everything in here, but object preservation takes its toll, and you end up with very much overhead in those files. All the data from the original object is in both formats. But if we import the CLI XML, let's do that from that temp file. And then we are seeing something that actually looks like our original process object, but of course not quite. And if we do get member, you always get the type name at the top. I could use get type as well. See, it's a system diagnostics process object, but deserialized. And if you read deserialized, you know exactly what that means. It's static. It will not change if the process changes, and there aren't any methods specific to that original object type.
What's the difference in size between those two files?
That's what I wanted to show. But as those are temp files, let me see if we can find those quickly. Yeah, that would probably be the CLI XML. Yep. So it roughly 60%. CLI XML will produce roughly 60% more output than JSON. Depends on the values that are in there. If there are many date type values, then JSON gets bloated because for that type, JSON has a rich representation that involves multiple fields. But if those are normal Scalar values, then JSON will be more concise. So then let's import that. And we ultimately see something similar. We can see that the information as such is there, but if we look at the data type, no surprises here, besides my inability to work the mouse. We get a PS custom object back. So no big surprises here. Now, let's do a little bit of state preservation and look at simultaneous access. It's a very dumb state preservation. I just list all the processes on this machine and take some properties out of those objects, and I just import the state if it was there before, or initialize the state as a hash table, which is correct for what I'm trying to do next, and then I compose a key out of the process ID and the machine name, and then I'll just add or update the state in the process information. So what's going to happen is if I start new processes, the state gets updated. If the processes start consuming more or less resources, the state gets updated. But if I stop a process, it won't get deleted from the state. It's just a dumb example, but something that actually could be necessary in your environment. So, and here's let me delete these two. So here's the CLI XML state. I wanted to go with JSON originally, and then I thought, yeah, you're not going to get the hash table back. So CLI XML in this instance is better suited, and as you can see, the file doesn't grow, no shrink. But if I start another process, we get more data in that state. Happy days, everything working. We keep writing the state, but let's see what happens if I go to another server and run exactly that same script on that. I did not change the color of my error messages. I'm sorry. So if anybody has a problem with that, please close your eyes. That will go away in a second. So the process cannot access the file because it's being used by another process. So this is that locking. We're writing out quite an amount of data at each iteration, and multiple instances separated by a network just can't cope with that. And you see that on the first machine as well. So it's not like the second machine is being hampered by the first. It's both of them basically fighting for that resource. So this is something to keep in mind if you need to actually write files from different sources. If 90% of those accesses are read access, you might get away with opening the file for read explicitly using some .NET stream reader or file classes, right? But ultimately, as the number of systems concurring for that resource increases, you will get into locking problems. We'll always get into locking problems with this stuff. Databases. We're running out of time here, so I will click through the slides, and then I've got some cool demos for you. So there are two database engines I wanted to show off today. Of course, SQL. Ladies and gents, for those who didn't know that, .NET and PowerShell support SQL natively without importing any modules since day one. SQL support has been in .NET, Microsoft SQL, obviously, since day one. So you can make a complete, and that hasn't changed with .NET Core, and that has been ported to Linux and Mac as well. So you can get a completely portable script accessing SQL resources. If you do that from Linux or Mac OS, keep an eye out for SQL patch and build versions, because TLS might get in the way of access. And of course, you need to figure out the authentication in a Active Directory domain environment. It could be easy because you could use Kerberos or NTLM authentication, but your Linux or BSD machines might not be thus equipped. There are, of course, modules for reading and writing SQL table data. No doubt about it, but and you are welcome to use those modules. SQL Server module from the SQL product team. I think DBA tools can do that as well, but then you have a dependency you have to ensure is there. What I definitely would like to talk to you about, and this I only learned like 5 years ago and have been using more and more ever since, is Sqlite. Sqlite is all over the place. All modern browsers use Sqlite. Visual Studio and Visual Studio Code use Sqlite. You won't find many software tools that don't use Sqlite these days. And here's why it's been so successful. It's free and open source. You are free to use it. It's completely portable. You just drop a DLL. Of course, you've got a dependency there, but it's a small DLL, or in case of Linux, these are 2 small DLLs, and you drop it somewhere on your machine where you can access that. I think with the proliferation of Microsoft Edge, you could actually find that DLL on your modern Windows systems if you know where to look. But I've never tried that in production because usually it's easier to just download that from the link and drop it beside your script. Sqlite does a SQL-like operations with local files or even in RAM. You can do in-memory databases with Sqlite for your script, and I will show you in a minute how you can drop your state into a file to persist it. Let's look at the demo. Sqlite, I will show you, it's the wrong server, of course. I will show you how big that DLL is. It's 2 megabyte on Windows. It's not really that big. First things, SQL. Of course, you need to create some database, and I mean, one day, like 7 years ago, I realized that I don't need copy and paste for this stuff. That I actually can write that from memory. It hasn't always been the case, but tab completion and IntelliSense help a lot. You need to import this namespace and then, or initialize a connection object. The namespace is actually there, like I said, and then you can do cool stuff. Basically, create a database. I think the database is there, and we would get an error message. Talk about idempotence. James Ruskin talked about it in the last hour. So, but since I know how the database is going to be named, I can go ahead and delete that and just run this. And I just created a database with a table. And I think you will believe me if I say the table is there. Here's something that you need to suppress in production. Any changing operation in this namespace returns a return code. And here is a small script that writes exactly the same state that we created in the last example, but it writes that to SQL, to that database we created. It's ugly code, it's convoluted code, but it does its job, and you have no dependencies here. So here are our processes, and if we go ahead and just start this same script on the second server, we aren't going to see any error messages because SQL handles this concurrent write for us. Sqlite. We need to import this DLL add type. It's located in the PS script root. It's up to you where you put it into. And then you don't need to create a database. You need to only have to create a database structure. This is the script that would basically create the same state structure that we do in SQL with some Sqlite specific differences. Grab the code after the conference of the GitHub. It's actually all there. And if we'd like to do that in memory, the only thing that changes is the connection string. We just write data source is memory, and we're done. The memory area is persisted in memory as long as the process is running. So if you exit your script, your database is gone. But for that, Sqlite has that nifty vacuum statement, vacuum as in Hoover, and that allows you to basically suck out a whole database into another database, and that other database can be on disk. To illustrate how good that works, I create two identical databases, one in memory and one in on disk. And then I create random data. Let me see. 100. Now let's make it 1,000. 1,000 records of random data. That's what the system web assembly is for generating random passwords, because I was too lazy to roll my own here. And we write that to memory, to the in-memory database, and gauge the time that is needed for that, and then we clock the time that is needed to do that on disk. And look at this. We need like 600 times the time to create the on-disk database, and that it takes to create the in-memory database, and then flush it per vacuum to that thing. In-memory databases can transcend run spaces. So this memory area where the in-memory database in Sqlite resides is specific to your process. It's not specific to a certain run space. So you can actually access that from any run spaces you create of your running script. And this is a piece of convoluted code that you're welcome to look at after the conference. What it does, it creates an in-memory database, and then it inserts one record in the outer script and reads it from every run space, and after that every run space inserts a record into the database and reads it in the outer script, and all that happens in memory. And of course, when we're talking run spaces, all of you work with PowerShell 7 every day. There is a legitimate question whether it's going to work with for each parallel, and the answer to that is yes, of course, it does that as well. So, we have 2.5 minutes left. There are a couple of other places where you could store your data. If you ever did IT on ships, and maybe not in the last couple of years, but earlier, you might get the bright idea to use your existing Active Directory to take care of the replication of your state. If you need the state worldwide, but you don't need it everywhere at once, why not use Active Directory? It's there. You can connect to it you can connect to your local domain controller on site, and then that guy will take care of replicating that to all the other places. Just don't use security-enabled objects for that, guys, because you, of course, have to grant access to those objects to your script. But there are plenty of objects and properties that fit the bill. Physical location type has a description property attribute, that is multi-valued, so you can use that. I've got demo code for that as well. Code, if you do that by built-in means without using the Active Directory module, the code will look messy, but it does its job and it's portable. It's not cross-platform yet. You can't talk to Active Directory from Linux or Mac with a built-in means of .NET, but I think that that is coming one day as well. Again, there is a sample code for that. If you've got connection issues, you could use a web service, because web services usually are more resilient against flaky connections, dropouts, and so on, to store your state on some system. Use a cloud storage, or write a simple REST API of the examples that are in Visual Studio and use that. So here's the takeaway for today. If you need centralized storage of large amount of data, large amount of changes, SQL is your friend. Cross-platform authentication needs to be figured out. Sqlite, ultra-fast local access, and ClarXML for best object persistence. Thank you very much.